Hello, I'm here for one more lesson of this T-FLEX analysis training course, and the topic for today will be the fatigue analysis. I've opened one model that it was used for to create the tutorial that you have inside the software, but for this purpose it is perfectly okay to show you how to execute this type of analysis. In fact, to create this fatigue study, we need to have two different steps. The first one, it is required to examine the effect of the static loading on the given workpiece or structure. In this particular case, it's only one part. So we need to perform a static analysis. And this is required in order to find out whether the workpiece damaged under the action of the given loads. If the workpiece experienced damage for that given static load, then it does not make sense to carry out the fatigue analysis because we need to change the structure of the part in such a way that we have this steady with the loads that are applied. And when we say that it should not experience any damage, we have one of the results. In this particular case, the safety coefficient should be bigger than the value 1. So let us see how to make all these steps, in particular the first ones, the static analysis. We will start to create a new study. You know this already. So static strength, let's choose all the necessary parameters. So create a mesh. In this particular case, I will use a 0.05. It will take a couple of seconds. So we have this. We could do it with a smaller mesh, bigger mesh. It depends on many things, but for the purpose today, it is okay. Now let us create a full restraint in this phase. Okay, and that's it. I will create also a local coordinate system in the center of this circle, and I want to have the z-axis pointing to the axis of this part. So I will rotate it. This is the y, so let us apply rotation, and now the z. Okay, it is okay like this. So it is created. Going back to the analysis, now I want to create a partial restraint in this phase and also in this phase, and I want to use cylindrical. I want to choose this local coordinate system, and I want to have it radial and by rotation axis, so something like this, and that's it. And finally, I will apply a load. In this particular case will be a torque in this face here. The axis is this one inside and 65 of torque, so something like this. Okay, solve. I want to solve this, so I can choose different parameters here. In terms of results, I could put all the results. I don't want, so I want to check in particular this factor of safety by equivalent stress. Okay, and let's execute the calculation, and we should have a couple of results. So two results. the one I'm particularly interested is this one, because the idea it is not having values lower than 1. So you can see already here that my minimum is 4 point something, so EALF 4.475, and we can see by the colors that it was expected to have a concentration in these areas, but it's not less than 1, so I'm okay with this. Having this okay, we should go now to create a new study, this time for the fatigue. The first step that I want to do, it is to apply what we call a curve, a special curve for the material of the given workpiece. And the idea here, it is to apply this law. So I will define it by study. I don't have a fatigue law. I will open one of the files that correspond to this fatigue law for a given material. I have them already in my installation. You have it already also in your softwares. So I will choose this steel alloy, and it is done. It is defined. Okay, good. And I have also to create now the study, so new study, and I will choose this time fatigue. Okay, and because the fatigue uses what was calculated on the static, I need to create an event now, and I must insert which is the study that we will check. So study, we can insert the number of cycles that are applied to our part. We can give the load type, which can be symmetric, a pulse, or other. I will leave this in symmetric. Correction or not, and we have a couple of different possibilities. You can check a little about what each one of these correction parameters are used for. I will say no correction, and in terms of scale, I will leave like this. So apply it, and at this moment I have all the parameters given and resumed in this dialog box, and I have also parameter important one, which can use this factor for amplify the stress concentration in some areas. List of results, I can use all the results, and basically it's a go for calculation. Today, in our particular study, we have a slight problem because this current version, and I will try to calculate. As you can see, we have a couple of errors going on when the calculation executes. This is not normal because we have a little bug in this version, but I will jump for a previous a file saved in one of the previous version, which already shows the final result of the calculation. And we need to make this small jump in this particular part to check what it was expected to obtain from the calculation. So we have different results. You see the axillity, the damage by equivalent stress or by normal stress or stress intensity, the safety factors, and we can analyze this. All of these different results have different meanings, but basically if we see a lot of red areas, these are the parts where we should have problems. Let's try to see a couple of results, see some differences. There are some three results interesting. Also, the total life in terms of stresses. So we have the number of cycles, and if there are parts in our model that are more fragile, as you can see, we have these in different coloration, showing clearly areas with problems. So this is basically this one. It is interesting also. This is basically the steps you should do to create a fatigue analysis. Today, with this particular and not normal topic of this small bug that we have when we execute the calculation, but this is something that it will be very shortly solved, and it's a normal process when the software evolutes. So any question, any detail that we might have skipped in this video, let us know and send us any special cases or any models that you are having problems doing the calculation, because as you know already, we will give you all the necessary support for the questions that arises from your work.